Okay, so let's go step by step on how to create a program in Designer Pro. So we're going to start by adding a blank rung. We know we have the first pass rung, so let's add, I guess, a couple more. Okay, down here at the bottom, I'll go ahead and insert the first pass. I don't like the background color too much. Let me change that. Let's go with that color. That's good. Okay, so I'll double click first pass. And on the top rung, we'll have an open contact with first pass and a move instruction. So move instruction will cause the system to go back to state 0. So we're going to move a 0 into state val. So it assigns state value to register 1, which is great. Unsigned integer 16, that's fine. Okay, so that needs to be a closed contact. Let's replace with a normally closed. Okay, so not finished the first pass, reset back to 0. And you know, now that I'm looking at this, it's something we could consider. You know, in some systems, I may not want it to go back to 0 when I come up from let's say, a fault condition, because that basically resets the machine back to a startup condition. Maybe you want it to remember what it was doing before the power failure. So if that's the case, what you could include is some kind of a push button here instead of a closed contact that you would have to manually restore it back to the startup condition. Because, you know, right now it seems fine to have it reset to 0. However, it could be that your system is processing products, and if it goes back to 0, it causes scrap or gets, damages itself. So there are a lot of considerations to be made. I think for right now, we're just trying to have a system that starts up in a known condition. And a manual reset would be a great way to go. What you could do is include like a start stop that you have to start the system, and before you can start it, you would select whether to reset it or not reset it. So that would be something to think about. So let's add that in since we've just talked about it. So what I will do is I will insert the rung above right here. And let's do just that. Let's do an open contact called stop push button. Okay. And then we'll have another open contact called start push button. Okay. And we'll have a coil, just a regular coil over here called run. And of course, we'll have a seal-in around start. So what I'll do is pull down this wiring tool and just sketch a branch in here around start. And I'll put an open contact here called run. So that will seal in the operation of the system. So on the reset, what I'll do here is I'll change this one. I'll copy the run contact and I'll paste it here. Well, that didn't work the way I wanted. Let's cut that. Let's move this over. So if run is on, then I could press a button called state reset if I wanted to. That would force a reset to state 0 and make it go back to 0. So I can't think of any other concerns there. The only problem is if I accidentally bump the state reset button at any time after I turn on the system, I'll go back to 0. So not real happy with that. Maybe we could put a time requirement on state reset. So let's do that. I'm going to delete this, and just right here I will put another contact called run, and I'll put a timer out there. It's an on timer. We don't need milliseconds. We'll do tenths of seconds. The register can be run delay. Let's make it called reset delay. Reset delay. Preset value, let's say a 1 second preset. So I'll have to hold down the reset state push button for 1 second before I can reset the state to 0. So that sounds good. That's a filter that prevents me from accidentally bumping the switch and resetting back to 0. So this will be called reset delay.done. Perfect. So now I hit start. I go to run mode. You know, it wouldn't hurt to have a delay on start or a delay on stop as well. You know, because realistically, if you bump a push button, you really don't want anything to happen except for an e-stop, but that's hardwired anyway. So it wouldn't hurt to have a time delay on stop and also one on start. So maybe a half second or quarter of a second, you know, just to filter out a random bump. But if you get into run mode, you can then I need to put a run contact down here as well. Let me add that. So if I'm in the run mode, I can press the reset state push button, and then I can get the timer to turn on, and that will force a reset on the state variable. Okay, so that sounds good. Let's patch this up a little bit. I'd like to have run on the left side. Reset can be on the right side. Doesn't make any difference. It just looks better to me. So that would take care of the reset back to 0. So there's no automatic reset now on this one. So if you're in state 100, when it comes back up, it'll be in state 100. I guess that's okay. That wasn't the original problem, but might have to think about that a little bit more. You know, we probably, I think it's okay. I'll worry about every little detail. Like, for example, what if power fails and it comes back on? Well, it won't go right back into run mode because has not been enabled. So if we get it back into run mode, it will pick up where it left off automatically. So I guess that's okay. It cannot restart by itself. We just have to include the run contact throughout the ladder logic so that, especially on the outputs, so the outputs can't turn on unless you're in run mode. So we can take care of that a little bit later. Okay, so here's start stop. Here's the reset. You know, I really probably should cut this and put it below the timer because, you know, sort of flows that way. So we hit the reset state push button, timer goes off, reset back to 0, or it doesn't go off, and I go into the previous state automatically. Okay, well, let's leave it at that for now. Something still bothers me about that. that if you go into run mode and you don't reset it, you will resume where you were. So maybe, maybe we'll include something like a 2-second delay, so that you have to be in run 2 seconds before the system will restart for any reason, whether it's where it's going to pick up or whether you press reset state. Let's leave it at that for now. Something still bothers me about that. You know, I like the operator to have control of when it restarts. I don't, what if they mean to reset it back to state 0 and they just forget for a few minutes and then come back and it's already taken, restarted where it was. So, I guess what we need to do in reality is add one more line here. So let's add one more line, and we're going to call this run. Okay. And what we're going to do is we're going to have a push button called resume. Okay. I know we're adding a lot more to this than what we started out with, but it's okay. So we're going to have a resume push button, and when you press it after you've been in run mode for any length of time, then the coil, not the set coil, but the coil known as OK to run turns on. So you have to not only start it, but you have to resume operation. Even if you're resetting back to 0, you still have to resume operation. So I like that. This puts control back in the hands of the operators. Nothing will happen automatically. Okay. Okay, I like that. So let's do an OK to run there. Makes me feel better. So let's walk through it one more time. Power fails, comes back up, nothing happens. We press start, we get the run. The run is on, the run is on, the run is on here. If I press resume at this point, OK to run turns on and the system restarts where it left off. Okay, if I press reset state at this point for 1 second, I will clear back to state 0, and I still have to press resume to make it restart. So I feel good about that. Okay, so I'm going to push this down. Blank line there. So we haven't done anything as far as the states go yet. So let's do that. So let's say that while we're in state 0, that's going to be an equal to. Okay, so we'll say that if state val equals 0, then we'll do something. So on the original project, we were using the start push button to do certain things, and we've modified that project a little bit here. So let's say that when we're in state 0, nothing happens until we press until we get the OK to run. That makes sense. So let's do an OK to run right here. Okay. Oop. Wrong button. Double click. OK to run. When we press OK to run, or when we get the OK to run contact, we're going to move into state 100. Okay, so we're going to put a 100 into state value. Okay. So, let's not make this too complex because it's a modified project already. So let's add a rung above that. Well, let's put it below. So let's cut this one and let's paste it down there. So here, if we go to state 100, what we're going to do is just turn on a fan, let's say. So I'm going to copy this instruction. So if I'm equal to 100, I will turn on a fan, which would be state, 100. Got an output coil. So let me pick up an output coil here. I'll call this fan. Okay. So if I get to 100, fan turns on. if I was in 100 and I press resume, I will just go ahead and restart the fan, okay? So I need to include the OK to run contact here because I don't want it to just restart immediately. I need for it to be OK to run. So I'm going to copy this, paste it right here. Okay. So state 0, I get the OK to run, go to state 100, it's still OK to run. I get the fan runs. So if power fails, here's the interesting thing about it. If power fails, the OK to run CLN will turn off. Everything will turn off. The fan will turn off. So let's say I'm in state 100. When I press the start push button, I get run. Run is here. It's ready. I can either reset it or I can not reset it. So if I just press resume at that point, I get the OK to run and I'm right here. The fan turns on. So the OK to run contact, or permissive they call it, needs to be in each of the outputs. If I had 17 outputs, they would all need the OK to run permissive in that rung so that they don't just turn on immediately when power is reapplied and you press start. Okay. So this right here, that's going to be an automatic thing. Once I press resume, I get out of state 0 automatically. So it looks good to me. That's fine. So I'm in simulator mode, so I will go online with the simulated controller, and I will right click and go to monitor mode. So I've got the red and green on this thing. So these are off right now. I'm going to right click, turn on the stop push button, because if it's normally closed, it's on right now. Of course, everything else is off like it should be. This is on. We expected that. And I don't even have that anywhere because I took out the automatic reset. So we'll just leave it down there. It's not hurting anything. So let's go ahead and press start to start this thing up. And I will release the start push button. I've got run. I'm in state 0. You can see right here. So let's not do anything to it. Let's just press resume. Okay. Hit resume. I can release resume. Okay. OK to run is on. The pump is on because when I get the OK to run, I go from 0 to 100. I'm in 100. Everything's good. The fan is on. So if I press stop here, what happens? Well, I'm still in state 100 because the stop doesn't cause it to leave the state that it's in. But let's say, this time I'm going to start it, but I want to reset it because you can see it's in 100. So let's press the reset button for 1,000 milliseconds. And I think I just put a 100-second timer in there because it was in 100 millisecond increments. So let's see if I can change it on the fly. Let's change that. I didn't mean to do that. So let's go with a preset of, let's see, 100 times 0.1 is 10. So 10 times 0.1 is 1. Let's go with that. And let's go back to monitor mode. Okay, so reset state is done. I go back to state 0. Now I can press resume, and I can, of course it shoots straight into it because when I hit resume, I go back to OK to run, and that just fires it through. If this coil was not the trigger right here, if I had a push button or something, then I could control it just a little bit better. But it works, the way I've got it drawn up here. So let's turn that off. Let's hit the stop button, turn it off, turn it back on. It works pretty well. The problem you'll find that you'll have with simulate mode is that the more complex your projects become, the more difficult it is to tell if it's working correctly by scrolling up and down inside the ladder logic. But by grouping the triggers and states together here, you can at least see which state you're in, and of course, how does it get out of the state? How does it move between states? So really, your state diagram is going to be critical. It's going to be your roadmap to walk through the different states you need to be in. And as long as you follow the state diagram, it's very difficult to mess up. The only thing that could mess you up would be perhaps some kind of a counting operation that you think it's going to count to a certain level and it doesn't. I mean, something minor like that will not let your program run correctly. But the state process controls how it moves, how it moves between states. And as long as you follow your diagram, it's very difficult to mess up. So that brings us back to the state diagram. It really needs to be where you start every project. It's very tempting even for me to just jump in. Like all this stuff right here, the start, stop, push button. I mean, you really should only activate that if you're in Power Up. But because now we don't automatically go back to 0 on the states, we don't want to put a state condition in front of it. This has to be live all the time. This one, this one you could say if you're not in state 0, I guess, but I think I would just leave it alone. But the danger we run here is that anytime we're running, like right now, anytime I'm running, whatever state I'm in, I could hit reset state and go back to 0. So that's a little risky. That's why we have the 1 second filter on it. So, if you're like in your process, you might decide that, there are certain states where it's too dangerous for anybody to do that, to go back to 0. So you could easily exclude those states. You would say right here something like state not equal to 200 or 300, whatever conditions you should prevent the reset button from working in, you would just kind of feed that in. So, you should never feel like you're out of control in your program because, as the designer of the program, you have total control over how it works. The state diagram is going to be key for that. So, just keep that in mind. It seems to get really complex at times, but it's really not supposed to be. You have a consistent pattern here of equal to and triggers and destination states. Then down here you have the actual outputs themselves. So for each output you'll have a rung. The inputs tend to be the triggers, but in this case it's inputs and conditions. So that's fine. Okay, well I think that's enough on this one. So I'll stop the recording.